My name is Dr. Seth Kessler, President of Metis Design Corporation, and today I'll be describing our Fastener Attrition Sensor Transducer, or FAST system, for damage detection in complex fasten joints. Metis Design is a small, high-tech R&D firm that offers novel multidisciplinary solutions for the defense and aerospace industry. Our work is principally in the area of structural health monitoring, nanoengineering, and multifunctional structures, where we have transitioned multiple disruptive technologies through licensing agreements with major OEMs. Under this specific SBIR topic, NAVAIR sought novel means for detection of hidden damage under fastener heads for the sponsoring CH53K PMA. They desired a solution that was non-intrusive to the fasteners themselves or their installation and would provide reliable detection of flaws before they grew beyond the fastener heads and could become a more significant problem. Since it is impossible to test or simulate every possible static, dynamic, and environmental condition, conservative maintenance approaches must be used. Components like critical fasten joints must be periodically manually inspected, which usually requires significant structural teardown, limiting asset availability and increasing susceptibility to inadvertent damage. Thus, there is a need for reliable, automated methods for diagnosing precursors to visual damage in static structure to help drive condition-based maintenance. The Fastener Attrition Scanning Transducer, or FAST, is a patented approach for monitoring single-sided aerospace fastener joints. A piezoelectric wafer is integrated within an unmodified fastener post-installation in order to detect flaws in or immediately adjacent to the fastener by comparing resonant peaks. Damage in the form of cracks, corrosion, or fretting would either directly affect the fastener itself or the contact boundary condition between the fastener and its hole, allowing more compliance. The image on the right side of this slide illustrates a partially packaged fast sensor with its transducer exposed. The left-hand image shows the fully packaged fast sensor adjacent to the uninstrumented high-lock fastener for reference. Blind validation testing was conducted on a series of fatigue specimens. Aluminum tensile coupons were fastened together with titanium doublers using highlight fasteners instrumented with fast sensors. The test was stopped periodically to record the damage metric output by the fast system, and once the reading was above a pre-designated threshold value, the test was stopped. Subsequently, all the specimens were disassembled and the hidden cracks were measured. This plot shows the damage metric versus measured crack length and illustrates a roughly linear response of the sensor for damage as small as 20 thousandths of an inch. Another test conducted under this program was the instrumentation of the full-scale fatigue test for the CH53K. The figure in this slide illustrates changes in the resonant characteristics for a fastener of composite joints before and after damage was introduced in the form of delamination. The fast sensor was designed to be compatible with the ADAPT system on the chip platform. ADAPT is a miniaturized, ultra-low power distributed data acquisition system that can facilitate testing for a network of up to 64 fast sensors over a 100-foot long daisy chain connection. All of the power and data can be transferred through a single USB-C access point placed in a convenient location. The system has achieved a TRL6 by being validated through a full-scale test on the CH53K, and the ADAPT hardware itself has actually been approved up to a TRL7, having been flowed on an F-15. Our commercialization partner, Analog Devices, has secured an exclusive license for manufacturing and sales of the ADAPT hardware and are presently producing these components on a low-rate initial production line for customer evaluations. The key features of this system are that it's extremely small, featherweight, and ultra-low power. It will work for both metallic and composite fastened joints and can be used without impacting the fastener itself or its installation procedure. Overall, this sensor allows for the greater asset availability by eliminating the need for structural teardown and manual inspection by experts. We are seeking additional programs of record who are interested in evaluating this technology for their aircraft-specific fasteners and configurations. We are particularly seeking opportunities for flight validation field trials. Thank you for your attention, and please reach out to me directly if you have any questions.